Okay, let's review the three forms of linear equations that we have. We have the first form, which is the slope-intercept form, and it goes y equals mx plus b. We have our second form, which is called standard form, okay, and it's typically written as ax plus by equals c. And then the third form, we use very common when we have a point and a slope, is called the point-slope method. Point and slope form. Okay. And that one is typically written y minus y1 equals m, your slope, times x minus x1. Now, we know that there's often we are not given the slope or the intercept. We may not be given a slope and a point. Often we're just given 2 points. And so when you're given 2 points like x1 and y1 and x2 and y2, of course you must be able to find the slope. And we know that the slope is m equals y2 minus y1 divided by x2 minus x1. So when you're working with these, it's very essential that we have at least 2 points, or a point and a slope, or a slope and an intercept. Those are kind of some things that we have to have in order to be able to write the equation of the particular line we need. Now, once you have, when they're in that form, they're fairly easy to graph. And so I'm going to bring a little paper over here and put it in here, and I'm going to show you. Here we have them in slope-intercept form. Of course, we know that our equation is, of course, again, y equals mx plus b, where m is the slope and b is the y-intercept. So if we look at this problem, our slope is 2, our m value is 2, and our y-intercept is 3. Very easy. If we look at this one, our slope, this sometimes confuses kids, but that's a negative. It's a -1, of course. And if you need it, you want to write it so that, you know, any of these slopes, you can write them as fractions, because we know we like to have the rise over the run a lot of times when we're graphing them. So you might write it as 2 over 1, and you might write this one as a -1 over 1. And our b value, of course, is a +1. Here we do have a rise and a run, 2 over 3. Our y-intercept's a -2. So just looking at these three problems real quickly, it's really easy to graph them. Your y-intercept's where it intercepts the y-axis. And of course we know our y-axis is the up and down axis. It's our vertical axis. So we know at 1, 2, 3 it will intercept our axis. Then this slope means we go up 2, which it kind of goes off the graph, but we'd go up 2 and over 1, put a second point. And so we have our 2 points. Here we have an intercept of y equals 1. Okay, our y-intercept's +1. And we have a slope of a -1 and 1. So we go down 1. Always put your negative on top, and that way you go up and down 1, and always run to the right. If you put your negative in the numerator, then you know whether you go up and down, and always will run to the right direction. So here we're at a -2 is our y-intercept. We go up 2 over 1, 2, 3. Bang. There's our equation of our line. Here again, we have a y-intercept of 4, a slope of a -3/5. Again, go up 1, 2, 3, 4 here. And now this way I'll look at this as a -3 over 5, so I'll go down 1, 2, 3 over 1, 2, 3, 4, 5 here. Okay, and we can draw this in, our line in. Very quickly, -3, 5 halves. Okay, we'll go to a -3, 1, 2, 3, our intercept, up 1, 2, 3, 4, 5, over 2. There's our line. Okay, I think we're getting the hang of this now, -1 and -1/4. We go to a -1, a -1/4 would be down 1 over 1, 2, 3, 4 is our second point. Connect the dots. Now you can see there's tables on all these. Of course we can go back to the old traditional method of putting a 0 in and a 1 in and a -1 in and plotting the points. You put a 0 in here, you get 0 plus 3, which is 3. Put a 1 in there, you get 5. Put a -1 in there, you would get 1. And we could plot those 3 points. All 3 of those points would be found. 0 and 3, 1 and 5, -1 and 1. Okay, a -1 and, 1 should be on there. It's a -1 and 2, it looks like. I didn't get my line drawn straight enough. Okay, well then let's look at some that are in standard form. We move this up to standard form. Here we have them in standard form. Now, these are really easy to graph too. A lot of teachers will teach you to solve for y and get it in the the slope-intercept form. But I like them in standard form because I use a method just called the intercept method, and I just cover up the x and I solve for y. Y would be equal to, if I divide by a 2 and divide by a 2, it's equal to a -3. So 1, 2, 3. There's my y-intercept. Now if I cover up the y value, I'll do it with my pencil so you can see 3x equals a -6. Divide by 3 both sides, we get a -2. There's my x-intercept, and I just connect those two dots. Again, I could make a table if I wanted to, a little more time. So now again, I'll get my y-intercept by covering up my x. I'd have to divide both sides by -4. That will give me a -1. Cover up here, I have 2x equals 4. Divide by 2x will equal 2. See, I can do this almost quicker than I can do this. So again, cover this up. 10 divided by 2 is 5. So my y-intercept's 1, 2, 3, 4, 5. There's my y-intercept. Cover this up. Divide by -5. My x-intercept's a -2. Okay, and I can graph those in. Okay, again, cover up here. 12 divided by 3 is 4. So my y-intercept 1, 2, 3, 4. Okay, cover up this. Oh wait, cover up this. And 12 divided by 6 is 2. So there's my x-intercept. Graph them. This one's easy. To get my x-intercept, x equals 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. My y-intercept, of course, is a -3. 1, 2, 3, minus. Okay, and connect the points. Over here, my y-intercept's 3. 1, 2, 3. My x-intercept, of course, is 3 divided by 3 is 1. So it's here. We connect the dots. Now that's great. You can see how quickly you can graph all of those. No problems. Looking back, we have one other form here, though, that I wanted to address, and that's that point-slope form. So let's look at the point-slope really quickly. Point-slope form, again, is y minus y1 equals m times x minus x1. This is, I think, the most useful equation when trying to write an equation of a line. For example, if they give me a slope is 5, and they give me a point is 2, maybe 3 or something, and they say write the equation of the line that has a slope of 5 and goes through this point. Well, it's pretty simple. There's your slope. So you put a 5 in. And here's a point that is contained on this line. So we can put it in place of our y1 and x1. This is our x1 and this is our y1. So we would just go y. Oh, let's put it up here with this. So I'm going to go y minus my y value, which is 3, times the quantity x minus my x value, which is 2. Done. There's your equation of your line. Now, of course, if you wanted it in a different form, which they often do, you can then just use your distributive property. Y minus 3 equals 5x minus 10, and we can plus the 3 over, and we would have y equals 5x minus 7. Now it's in, slope-intercept form. We can move the 5x over, put it in standard form, whatever method we wanted to do it that way. Again, using this equation, what if they give me 2 points? Okay, they say give me the point 1, 5 and -2, 3. And it says find the equation of the line that contains these 2 points. Well, once again, I told you we always need our slope. So let's find our slope. We'll take y2 minus y1, so 3 minus 5, over x2 minus x1. Okay, so that gives me a slope of a -2 over a -3. So positive 2/3 is our slope. So again, we'll come down here and write this equation. I'm going to use this equation. I'll just choose either point. Either point will work because it's a point on the line, and I have a slope and either point on the line, so I'll choose this one. So I'll go y minus 5 equals my slope, -2/3, times x minus 1. And then I can manipulate this into slope-intercept form or standard form, whichever way I'd want to do this. Okay, so you can see that it works fairly easy to do it either way. You can graph off of this really quick. I'll show a quick graph. Say I have an equation y minus 2 equals 2x times the quantity x plus 3 or something. And it wanted me to graph this. Well, I know my slope is 2. And I know a point on the graph happens to be, now it's a -3, because remember our equation had a negative. So it's a -3 would make a positive, and it's a +2 here. So here's our point. We'd go over 1, 2, 3, and up 2. There's our starting point. I refer to it as a starting point, and then I use my slope. I'm going to go up 2, so I go up 2, and over 1, so there's up 2. Over 1, I connect those dots. So there's a lot of different things you can do with that. I hope this will help you if you get stuck during the holidays. Have a good time. Enjoy your Christmas. Goodbye.